card was late.
Thanks, Julie, and thanks, Zandy, and everybody else at the park for giving us this opportunity to come talk to you guys about some about what we've been up to the last couple of years. Okay, so I'm going to give it just a little bit of an introduction about corals and coral reefs in the Caribbean. I wasn't sure what the audience was going to be, so I think a lot of you might know some of this, but we'll go through it anyway. And then Madelyn is going to come and talk some about some of the work that we've been doing the last couple of years here as part of her master's thesis. She's going to be finishing at end of this summer, which is very exciting. Some of the work we've been doing on grazing rates and behavior of parrotfishes in St. Croix. Okay, so as many of you know, Caribbean used to be a pretty amazing place. You know, lots and lots of live coral, tons of huge fish, but it hasn't been that way in a while. There was a geologist who started shooting video in Florida on some of these reefs in the 60s and 70s. He went to the same places and took photos, and you can see over time these corals, this is the exact same spot. These corals are basically turning into rubble, turning into just dead reef, right? So you've got this nice coral heads in the 60s, you've got the staghorn starting to explode in the 70s, you know, so much so that the staghorn is actually overgrowing these mounding corals. A little disease picked up in the early 80s. By the late 80s, the disease had wiped out most of the staghorn. Now you can see that huge staghorn thicket is now just kind of like a pile of dead coral, and this is what some of these reefs look like today. It's a lot of gorgonians, a lot of dead standing coral, right? And for most people who have never seen a reef before, they think that's normal. They think that's what it's supposed to look like. And that's not what the Caribbean, that was Florida, but the story in Florida and some of the data that we've got are really similar to what's happened across the entire basin, right? Across the entire Caribbean. Okay, so what's going on? What is ailing the Caribbean? What are some of these things that are driving some of this loss of coral? Well, one of them we call land-based sources of pollution. This is basically a catch-all phrase for basically anything we do on land. Remember, everything runs down towards the ocean. So anything we do on land, you know, pollution, adding fertilizer to fields, cutting down forests, runoff, all this stuff eventually ends up on the reef. So this is somewhere, I think the south coast of Puerto Rico, I believe, and you can see there's a river coming out kind of right in the middle with a little bit of sediment and a coral reef, right? You get a major rainstorm, and this is what we see not long after that, right? So if you're a coral, you like living in clear water with lots of sunlight. You've got, you know, lots of little microscopic algae living inside your tissues, and so you're photosynthesizing and you're really happy. And when you get a runoff event like this, the visibility goes to zero, so you can't photosynthesize very well. You get covered in sediment, which makes it hard for you to do stuff. You get clogged, and you end up killing a lot of corals. And of course, you know, when you get major rains, this can happen, but this has been exacerbated by everything we're doing upstream, right? And these are what we often think of as these non-point sources. You guys have probably heard of point source and non-point source. Often these are non-point source. We don't know where all this stuff's coming from. It ends up in a river, kind of ends out on the ocean. Sometimes we can actually identify a point source. This is a sewage outflow off of Broward County off of Fort Lauderdale in Florida. I guess it's been partially treated. I have no idea how they got permits to do this. It must have been done a long time ago. So you see this is several miles offshore, and there's this outflow, and if you look carefully, you can actually see a bunch of fish swimming in it. And the divers intelligently are upstream of that. Anyway, you can imagine there's a bunch of nutrients that are going to be coming out here, and so, you know, even if it's just a point source, there's a bunch of nutrients that's going to be helping to fuel the growth of algae, which is going to compete with corals. So that's one problem. Another one is disease. Guessing a lot of you recognize this little critter here on the left, right? This is the long-spined sea urchin, otherwise known as don't step on it. Anybody ever gotten on spines of these guys in your foot? Yeah. One of my dive buddies when I was a grad student on St. Croix actually was swimming out backwards and bumped into a reef that was covered with these guys. He had a close friend of his help pick those spines out. Anyway, so these urchins are also really important herbivores, right? Herbivores, they eat algae. They basically sit essentially with their mouths down on the reef and eat the algae that's on the reefs. They're really effective at doing this. And they used to be really abundant throughout the Caribbean. Then in 1983, a disease basically swept through the entire Caribbean over the span of a couple of months, and we had urchins that went from this to this. They basically just had this wasting disease. They lost their spines. They died. And I have some friends that I used to work with when I was working in Miami who were doing surveys when this disease hit Florida, and they said, like, on Thursday we went out to this reef and it was covered in urchins. When we went back on the next Tuesday, all the urchins were dead, and they could see these spines. The urchins had basically just sort of like fallen apart, essentially melted. Right. So when this disease hit in a certain place, these urchins died very, very quickly, and the total mortality was something like 95 to 97% or more of each of these urchins died in each of these individual places. And so if these urchins were one of the main things that were helping to keep back the algae, when you lose 97% of them, the algae is going to take off, right? Algae overgrew coral, so that's another problem. And of course, back then we didn't know about our newest fun threat called climate change, right? We know that the oceans are getting warmer. I'm sure that you have noticed it here, that every year you get, more likely to get reports of coral bleaching, increased water temperature. This is the trend over the decade. So we see where we are in the Caribbean is somewhere 0.3 or 0.4 to 0.5 degrees Celsius per decade warmer. That means the trend has been getting about half a degree C, which is basically about 1 degree Fahrenheit warmer every decade. It doesn't sound like much, but if you're a coral kind of living at your thermal limit, that can create a lot of stress. And so what happens when the water gets really warm is we go from a nice, happy staghorn coral looking like this to a bleached coral. Basically what happens is they've got these little microscopic algae living in the tissues of this coral. So the coral is kind of like we call it the symbiont. It's basically like a partnership between the coral and the algae. The algae photosynthesizes and gives the coral some sugar, some food, and the coral gives the algae protection. But when it gets too warm, this happy relationship breaks down, and the corals essentially kick out their algae. They turn white. So that coral on the right is not dead yet, but if that continues to happen, it's going to be. And so this is a bad process and happens when the waters get a little bit too warm. And ultimately can also stress the coral, so they're more likely to get disease, and all kinds of other bad things are likely to happen to them. Right? So when we have increased warming, we tend to see more of these bleaching events. We call coral bleaching when they lose their color. Of course, increasing warmth also leads to more hurricanes. I don't need to tell you guys here anything about that. And then, of course, how many of you have heard of ocean acidification? What we sometimes refer to as global climate change or global warming's other evil twin. Basically, as we're pumping all the CO2 in the atmosphere, some of it dissolves into the water. That makes the water slightly more acidic. Since these corals are laying down this skeleton of calcium carbonate, which is basically limestone, which dissolves in acid, as we're making the waters just ever slightly more acidic, it makes it that much harder for them to make their skeletons, which, again, with all these other stresses, just makes life a whole lot harder. Okay, so we've got climate change, and then of course we've got I don't know if I call it the elephant in the room, the grouper in the room. Of overfishing, right? We all know that that there used to be a lot more fish in a lot of parts of the Caribbean. And you go to a market, and sometimes you see a bunch of our favorite parrotfish sitting on the display table. But a lot of the Caribbean used to look like this, right? Used to be loaded with sharks everywhere. If you read the historical reports of the first European explorers that come to the Caribbean, they would say that as they're trying to row ashore to some of these islands, there are sharks, like dozens of sharks attacking their boats, attacking their oars. They were everywhere. We see those anymore? No. There also used to be, these massive grouper. Anybody ever seen these grouper here in St. Croix? Yeah. Anybody see them here in St. Croix? Or anywhere else in the Caribbean for that matter? There's a few other places. Where have you seen them? In the Keys, okay. Right, but not, yeah. So in the Keys you see them some. The funny thing about these grouper, they used to be called Jewfish, right? And as a Jew, I thought that was kind of an honorary thing. You know, the largest grouper in the world was called a Jewfish. But then the folks at the American Fisheries Society decided that Jewfish wasn't politically correct. Some people might find it offensive. I'm not sure who, because I think it's a great name. And so they decided to change the name to the Goliath grouper, right? Because Goliath was big. But anybody who knows their biblical history knows that Goliath tried to kill the Jews, right? Anyway, that's the American Fisheries Society for you. But anyway, the Caribbean used to be filled with huge sharks and huge groupers and Nassau grouper everywhere, right? These fish were everywhere, and now we just don't see them in those kinds of numbers. And sometimes we even saw what we think of as herds of these parrotfish. These are midnight parrotfish moving through quite literally in a herd. They're like cows. And here they go, kind of growing over a reef. You can see there's some poop flowing behind them, because that's what they do. And then they'll find a little patch of algae, and they'll all sort of go attacking and biting and moving around. And you know, these are fish that are, you know, 2 feet long, sometimes bigger. These massive schools of these things. Has anybody ever seen one of these schools in St. Croix? Okay, anybody has seen one of these schools in St. Croix in the last 40 years? They used to be here, but they're not anymore. And so we've gone from these really healthy reefs with lots of fish and lots of stuff to something that looks like this, right? And again, if you don't know what a coral reef looks like, you think, oh, it's pretty, the water's clear, it's really warm, it's a lot warmer than, you know, like Ohio or where I'm from in Chicago. You go diving in Lake Michigan, you can't see anything. It's cold, it's well, freshwater, first of all, but there's this structure, but it's all standing dead, right? All of this stuff used to be live, and now you've got a few corals here or there living on dead reef, with a few gorgonians and a couple of other things, and this is not what this system used to look like, right? This is not what this system used to look like. And so, you know, we went from a system Caribbean-wide. Again, these are pictures from Florida, but lots of the Caribbean has shown the exact same patterns, where we had these stands of incredible amounts of live elkhorn, staghorn, pillar corals everywhere, so much so that you couldn't swim over this stuff without crashing into it, without it cutting you. That was 75. 10 years later, it's mostly dead, but still standing. 10 years after that, you know, we've lost a lot of the structure, and now this exact same reef went from this incredible three-dimensional structure to what is now becoming a flat plane, right? And you think about the critters that live in this habitat, they like all the little cracks and crevices under here, so they need this stuff. And so we're losing the structure, we're losing the coral. And so the question is then, what do we do about that? Well, part of the problem, we think, is that, you know, in addition to all these other things, that there has been this dramatic loss of this process that we call herbivory. Basically, critters that eat algae, right? We know algae grows really fast, grows a lot faster than corals, because corals have to like build this really hard skeleton to make their structure, whereas algae are just soft and they grow really quickly, and they overgrow corals and can compete with corals for space. And so if you have lots of these herbivores, are cows of the ocean, we tend to have less of that algae, which helps the coral do better. But as we reduce the abundance of these fish that eat algae, we then end up with a system that kind of looks like this. You know, this low relief, lots of algae, small fish. It's a lot less interesting, and it's actually a lot less productive and does a lot less of the things that we like reefs to do. So this is kind of the state of where things are going. And so I want to show you a little bit about what we know about where we've been, right? So on a coral reef, one of the main ways that we describe how healthy a reef is, we call the percent cover. It's basically the amount of the bottom that is made up of live coral. And we've actually got an example of one of these here. That is a quadrat. This is an essential sampling device for marine ecologists. Thank God PVC and cable ties have enabled marine ecology to go forward in the world. And people are laughing because they know it's true. And so basically we go out in a random spot, we drop the thing down, and we count under each of these little crosses what is directly underneath it. And so in this example here, you can sort of see there's a dot, there's a dot, there's a dot, there's a whole bunch of live coral. I don't know where that was. I've never seen a place like that. But a lot of live coral underneath that, and we count all of the things that are holding space. That gives us an estimate of like how much of the bottom, what percent of the bottom is occupied by different critters. And so if we do this, we have lots of people going out in lots of different places. We can actually come up with a trend line of what coral cover, the percent coral cover looks like over time. And what we see is this is a huge amount of data that was put together in the last couple of years. Basically, all of the surveys that they could get their hands on that anybody had done in the last 40 plus years, they put it into this massive database. There's a friend of mine who spent basically 2 years trying to clean and organize all this data so that we could actually get some information from it. But the general trend, what you see is, in the 1970s, the percent coral cover was 40, 50%, right? Like half of the bottom was live coral throughout the Caribbean. Now, the average is somewhere less than 20%. So we've lost a ton of it just over those, 30, 35, 40 years. And again, we see this sort of Caribbean-wide. That's what these data are all showing. But the trend has been similar in many individual places. And so then the question is, how do we fix this? We could stop global warming. That would be great, but that's a tall order. We could try to manage land and reduce our runoff, try to do that a little bit better. And there are a lot of places talking about what we call ridge to reefs that are starting to do some of that kind of integrated, thinking about the whole system. There's some of that's going to help. Certainly reducing the demand for seafood, eating less fish, especially some of the fish that fill these really important ecological roles on these reefs, is something that's going to help. Treating diseases is a challenge. Especially in some cases, we don't even know what the disease is, let alone how it's transmitted, let alone how to stop it. So that's going to be a really difficult thing to do. But one of the other things that has been really interesting to scientists recently and managers is increasing grazing. That is, increasing the amount of stuff on the reefs that's actually eating that algae. By reducing that algae, we're freeing up space to allow corals to do better. And so, interestingly, when we look at our Caribbean-wide data, right? This horrible decline from the 70s to the 2000s, and we break these data up into not just every place altogether, but we look at them based on how much fishing was happening at the time. Or what we think was how many of these urchins there were. The ecological relationship's kind of complicated, but basically, when we think there was less fishing, that means there were more parrotfish. Parrotfish eat algae. They also compete with the urchins for algae. So where there were more parrotfish, where there's less fishing, there were more parrotfish, there were fewer of these urchins. And so then when we see over time, the places that had less of that fishing, had more parrotfish, had fewer urchins, there were fewer urchins to die when they died. So there was less of that loss of what the urchins themselves were doing. And so what we see is that those places, when we break that out, those places are actually doing better. So those places that had more of these parrotfish, that had more of this process that we think of as herbivory, this algae eating process from these fish, actually seem to have done a whole lot better with their coral over the last 30 years after this fishing. And again, we're talking about fishing that was happening in the 70s, has still effects that we can see potentially 40 years later, 30 or 40 years later. And so that's been the focus of what our work has been doing. So we know that having more of this grazing will reduce algae and should help corals. Of course, it's complicated, especially in some parts of the Caribbean like St. Croix, where these parrotfish are important grazers, but they're also really important in fisheries, right? People like to eat them. And so if you say, you can't fish here, that's not going to fly. So we maybe need to understand a little bit better about how those things interact. And one of the other really important things, and this leads directly into Madelyn's master's thesis, is that not all of these parrotfish are created equally. They aren't all doing the same thing. So we need to have a better understanding about what different species of parrotfish are doing, so that we can better understand how many of which critters we need in order to maintain some of these ecological processes. And with that, I would like to introduce Madelyn Roycroft. And Madelyn's going to talk about some of the work that she did for her master's here on St. Croix to try to understand some of these questions.
Thanks, Ben. Any questions before we move on?
Oh, I forgot there's a microphone.
Oh, are we supposed to be using the microphone?
Clearly, I wouldn't use it. If you guys couldn't hear me, well,
All right, so for my master's research at Cal Poly, our first research question was, is there a difference in feeding behavior among the parrotfishes in St. Croix. There's been preliminary studies, and a lot of studies actually, in the Florida Keys with the Berkey Pile Lab investigating this question, but we wanted to increase our sample size throughout the Caribbean, so we're now focusing our efforts on St. Croix. And then, can we predict the amount of grazing on a reef using these components of their behavioral? So if each species does something differently, we need to incorporate that into our grazing estimates. So how did we do this? We quantified feeding behavior using a couple of variables. Number one is food preference. So do they prefer fleshy macroalgae, CCA, which is calcium carbonate algae, which is typically that pink crusting algae on reefs, or even live coral, or some of these other sponges, etc. So that's food preference. And then substrates targeted. So when they're feeding off of the reef, do they prefer a rubble habitat? Do they prefer a sandy bottom, or a more like hard pavement-y substrate, etc.? And lastly, their foraging habitat. So do they prefer a nice high relief, what we call spur and groove habitat, which you see at sites like Cane Bay and Long Reef? Or do they prefer patch reefs or sandy bottoms when they forage? So the main method that we use for our first research question is what we call parrotfish fish follows. So, and we did this at 3 study sites on the island: Cane Bay, Long Reef, and Buck Island. And we got about 6 fish follows per species at each of our sites. And to go into a little more detail, so how this worked, if this will play. So we had a diver tow a surface float, which has a GPS unit attached to it, and has a dive slate where we use underwater paper to record our data. And we follow at a far enough distance so that we don't scare the fish, but close enough where we can actually see what foods they're targeting, how many bites they took off of the food, and off of what substrates. And so this was we tried to keep up with fish for 20 minutes. Sometimes it didn't work at all, but we have enough data to actually make this work. So, and this was at Cane Bay, I believe. And this is me, and I was following a stoplight parrotfish, initial phase. So the data we recorded are their food and substrates that they targeted, the number of bites that they took, and also we have spatial data from this. So those surface floats that I just mentioned, which is below here, we had a GPS unit that recorded their tracks. So we were able to essentially, for every fish follow, have an idea of their foraging territory. So some fish, like the yellowtail parrotfish, take us many meters around the reef. And I believe this was Ben's track from one day, and it was some ridiculous amount of meters. But other fish, like our princess or queen parrotfishes, if you're familiar with those, they have a smaller foraging territory. So this was just some other useful information that we could gather while we were doing the behavioral observations. And so, what did we find? So these are our 6 parrotfish species that we did most of our behavioral work on. And the take home is that we have our deer and our cows. So if you imagine, deer typically forage off of leaves or trees or shrubs, and they pick off of those leafy, shrubby material. Our cows, on the other hand, typically forage more on the turf, the grass, and forage more closer to the substrate. So the 6 species that we see in St. Croix have similar behavior, where we have 3 species that are deer-like, so they target macroalgae, this fleshy, bushy macroalgae. And we have other 3 species that are more like the cows, that target the turf closer to the substrates and actually contacting the substrate while they forage. Does that make sense? Okay. And just to clarify, so our stoplight parrotfish, we have our initial phase, and or male and female initial phase, terminal phase stoplights. This is an example of one of those cow fish, so they prefer turf algae. And an example of the deer, so one that targets macroalgae, are yellowtail parrotfish. So on the top we have our male terminal phase, and on the bottom our initial phase yellowtail. So this is really interesting. We're seeing that different species perform different roles, target different types of foods, and often on different types of substrates. And this is great because this aligns really nicely with some other work we've seen at other locations, such as Florida. And also, they also have different bite rates. So 2 of our species in purple, on average, have a higher bite rate than our other 4 species. So this means that they are just nibbling at the reef at a higher rate. They're grazing at a higher rate than other species. So for our first research question, yes, we did find that different species perform different roles on the reefs, or our 3 study sites on St. Croix. And so next, we're going to see, okay, can we now predict how much grazing is happening at these study sites using this knowledge and also knowledge of what are the abundance and biomass of these fish at these sites. So for this graph, don't get too bogged down with the details here, but just note the relative height of each bar. So this is the total weight of all parrotfishes found at these 4 study sites. So we have our Buck Island Forereef, Buck Island Lagoon, Long Reef, and Cane Bay. And our different species of parrotfishes, these are all parrotfishes, are in different colors. So to note here, Buck Island does have a higher biomass, or total fish weight, than our Long Reef and Cane Bay sites. So that's really nice to see because this is a marine protected area. No fishing is allowed here. This is a good sign. And I'd also just to note that at our different sites, there are different total weights based on the species. So that's also just interesting to see as well. And so using that graph, the previous graph, and also the behavioral data that we have from our first research question, we were able to essentially determine how much of the reef is grazed per year by all of these individual parrotfishes. And Buck Island, Lagoon, and Forereef has on average a larger percent of the reef grazed annually. And this is also a really good thing to see. So the marine protected area, maybe this might have a role in why these 2 sites compared to Long Reef and Cane Bay are being grazed at a higher rate. And it also, the different colorations that we see is a sign that this is very much species-specific relationships that we're seeing. So this is something that we're still working on and still trying to tease apart as well. Any questions on that? Okay. So also not necessarily the elephant in the room, but there's also what we call coral livery that we as divers have seen, and many of you on the reefs might have seen as well, where a parrotfish actually targets live coral tissue. And that is a stoplight parrotfish. And although we have documented this in a lot of videos and you see lots of grazing scars on the reefs, we've, as a research team, we've deployed many cameras and have hundreds of hours of footage of coral livery that we've focused on a coral head with a grazing scar. And the past year, we only saw 41 instances of coral livery over 400 hours of GoPro footage. So this is a pretty rare event, but it's something that we're still looking into and that the new grad student, Hannah, is looking into for this upcoming 2 years of research. So typically what we actually see is just hundreds of hours of actually nothing happening on the reef. So luckily we have a huge team of undergrads at Cal Poly that get to have a nice study hall room with a huge projection screen and just doing this data collection for us. So it works out both ways. So in terms of future steps, our next step is really to figure out, okay, we know that different parrotfishes are doing different things, and also it might even be site specific. So we want to look at also the larger scale grazing effects, so to see how essentially, using all of the knowledge that we've gained across these sites and looking at the big picture of what's happening on St. Croix with the grazing estimates. But also, the next step is to look at, so we have all this grazing estimates, but what's actually happening to the coral cover? Can we see a relationship with coral health, and can we tie that to what we found for our grazing estimates? So that's something that we definitely need to look at over the next couple of years. And lastly, with this whole coralivery concept, we want to better understand the net impact of parrotfishes, because if we know that they target live coral, clearly that's not helping the coral reefs. But if they're also providing a net positive benefit from being algae grazers, then maybe they actually do have a net positive benefit. So that's why it's really important to also investigate this question of coralivery. And lastly, so there's a lot of management implications for this study, and one of them is so that we can better provide managers information on which habitats are best suitable for where the fishes will have the greatest impact on coral reef health. So that's why it's really important for us to take detailed notes on where the grazing is happening and how, if this grazing is happening on locations of reefs where coral health is the most important. And also, we can help by providing managers information or better information on which parrotfish species that we should maybe better protect based on their ecological roles on the coral reef. And also areas as well for that. So with that, we'd like to thank all of our collaborators and our funding, and especially the National Park Service for letting us give this talk today, and all the field assistants, etc. So thank you everyone for coming. Yeah.